Audible.
Audible. Hello, sir. Hi, students. So, in this session, we are going to discuss open circuit test and short circuit test. Now, the situation is something different, outside situation. You may be knowing that. You are well aware of the present situation, right? So the only way to communicate with the students is through online platform only, right? So that is why please cooperate with us, and if you have any queries, so please send to us. Definitely we will go through it and we will try to answer, and we will try to convince you to the possible extent, right? So in this connection, so first we have started our discussion with diode open circuit tests and short circuit tests, right? So this is one of the very important topic for engineering competitive examinations. You may be knowing that. In the next session, we are going to discuss problems are clipper circuits as well as clamper circuits. So what is a clipper? Clipper is a transmission circuit which transmits below the reference value or above the reference voltage or between two reference voltages. Right? So based on this, and Zener also can be used in the clipper circuit. Right? So based on that, we are going to solve a wide different kinds of problems in the next session. In this session, we will discuss open circuit test and a short circuit test. Right? So the prime motivation to conduct open circuit test and short circuit test is to observe whether the diode is in on state or in off state. Right? As long as the potential barrier exists, then the diode is said to be in off state. That means if the external voltage applied across it is insufficient to cancel the barrier, then the diode is in off state. Why? Because as long as potential barrier exists, so it never allows the majority charge carriers to cross the junction to constitute current. Once the current is zero, then diode is said to be in off state only. If we increase the voltage across the diode, which is greater than the threshold voltage or cut-in voltage, definitely the force due to the external potential opposite to the force due to the potential barrier, and hence it will be cancelled completely. The potential barrier is eliminated completely. Now the charge carriers cross the junction which constitute forward current. Now the diode is said to be in a on state. Right? So we know that the cut-in voltage for germanium is from 0.2 volts to 0.3 volts, and for silicon it is 0.6 volts to 0.7 volts. Right? So in general, silicon is more preferred than germanium diode. Normally we will take that silicon by default. If it is not mentioned explicitly in the problem, whether it is germanium or silicon, default case is silicon diode only. Assume that is a silicon diode only. And so very purpose of conducting, just now I have mentioned, very purpose of conducting open circuit and short circuit test is to observe whether the diode is in on state or off state. Basically, diode is a switch, true electronic switch, toggles between two states, on state and off state. Right? When the current conduction takes place, then it is said to be in on state. If the current conduction does not take place, that means if the external voltage is insufficient to cancel the barrier, then the diode is said to be in off state. Right? So once it is on state, then we know, then only it will be coming into existence to perform the task assigned to it. What is the task assigned to the diode? Rectification, which converts AC to DC, broadly speaking. But in practice, right, this is not possible, never possible. It is able to convert the AC signal into pulsating DC only. That you may be knowing this. right? Pulsating DC in the sense, so while converting AC signal into DC, it leaves some of the AC components in the output also. So hence you can say that the pulsating DC is a combination of AC and DC. So first, let us observe the open circuit test. Open circuit test. In this case, the diode is replaced by open circuit. This is diode, anode, cathode. This is replaced by open circuit, VA, VC, cathode voltage. Now calculate. We have to calculate VA minus VC. VA minus VC. If VA minus VC is found as greater than or equal to V gamma, that is 0.7 volts, then you can say the diode is in on state. Now the diode is in an on state. On the other hand, if VA minus VC is less than V gamma, then the diode is in an off state. Right? So if the circuit consists more number of diodes, more than one diode, then what happens? So the diode which is more heavily forward biased, that means whose VA minus VC is greater than other diodes, which will become on first. By the time other diodes will be in off state. Right? If number of diodes having VA minus VC greater than V gamma, then the diode whose VA minus VC value is greater than other diodes VA minus VC, then the diode will be switched on first, and by the time other diodes will be in off state. That means it is said to be more heavily forward biased. All right. So that is why it will be switched on first. That means if I will write down here, if number of diodes having so VA minus VC greater than V gamma, then the diode, in this case, the diode which is more heavily forward biased, will be switched on first. It will become on first. By the time other diodes will be off only. After that, so next we have to observe for diode 2, we have to calculate VA minus VC, and we have to observe whether it is in on state or off state by comparing it with the V gamma value, that is 0.7 volts. Right? So if for next diode VA minus VC is greater than 0.7 volts, then again we can say that is an on state can be replaced by V gamma. If it is ideal diode, so ideal diode in the sense, what does it mean? So in ideal diode, it is assumed that potential barrier is assumed to be 0. Potential barrier does not exist, and the diode resistance also assumed to be 0. Then the diode is said to be ideal. Right? So if the diode is ideal, then it is replaced by short circuit. Right? If the diode is practical means even if we neglect the diode resistance, but the potential barrier cannot be neglected under any circumstances. Potential barrier definitely will be existed in practice. When compared to the diode resistance, potential barrier resistance is very high, much high, which never allows the diffusion of the majority charge carriers from one region to other region to constitute electric current. That is the reason the potential barrier under any circumstances cannot be eliminated, cannot be neglected. Right? So under these circumstances, we have to replace the diode by V gamma, that is equal to 0.7 volts, battery of 0.7 volts, fixed voltage. Have you understood this? Right? That means, so I will write down here for ideal diode. For ideal diode, it is assumed that V gamma is 0 and diode forward resistance is also assumed to be 0, right? And reverse resistance of diode is assumed to be infinity. And schematically, it is represented like this. This is anode, cathode. And so that means when it is forward biased, can be replaced by short circuit. When it is reverse biased, it is replaced by open circuit. All right. So on the other hand, for practical diode, V gamma cannot be neglected, even if we can assume RF is 0, but V gamma exists. Means, what does it mean? To introduce current conduction in practical diode, the external voltage applied across the diode must exceed V gamma value. This is schematically represented like this. This is V gamma, and this is forward voltage. Then this is diode. This is how the practical diode is represented. In this case, what we have neglected? We have neglected diode forward resistance. Even that means in practical. So diode forward resistance is inseparably linked with it. Because of that only, the current through the diode increases exponentially, not abruptly, even if the potential barrier is eliminated completely. That we will discuss in diode concepts, no doubt. Right? Now we are doing some problems on this topic. That is why brief introduction I am giving. Right? So so V gamma cannot be, RF is neglected. That means once the potential barrier is eliminated, then the current conduction is introduced in the diode, which increases, assumed to be increases in a abruptly, not exponentially. When diode resistance comes into picture, then the current through the diode increases exponentially. Exponential increment. We know the diode current equation I is equal to I naught into e to the power of V by eta Vt minus 1. That exponential equation only will be coming into the picture between V gamma and V sat, saturated value. Right? So, and next one is short circuit test. Short circuit test. In this, each diode is replaced by short circuit, like this. This is diode, and this is replaced by short circuit, like this. And the current is assumed to be, this is anode and cathode, Pn. Right? Current is assumed to be directed towards from P to N. That is, the basic assumption must be taken into account to conduct the short circuit test. The current direction is assumed to be from a P to N, not from N to P. P to N. Right? Now the diode is replaced by short circuit. And if now calculate ID, current through the diode. If ID is greater than 0, then diode is said to be on state. On the other hand, if ID is less than 0, then it is said to be in an off state. As simple as that. Right? So in this way, the short circuit test is conducted. In short circuit test, the diode is replaced by short circuit, and the current direction is assumed to be from N to P to N only. And so if now calculate ID, current through the diode, if ID is greater than 0, that means current conduction is introduced, then it is said to be in an on state. On the other hand, if it is less than 0, off state. Right? So now let us see some problems on this topic. So for the circuit shown, calculate I1, I2, assume that the diodes are ideal. Just what I told you, ideal diode. What is ideal diode? Ideal diode is nothing but it is assumed that both the potential barrier as well as diode forward resistance is assumed to be cancelled. That means eliminated. Will not be taken into account. That is nothing but ideal diode. Correct? So, and in this case, let us replace both the diodes with short circuit. Replace the diodes with short circuit. Okay, short circuit. Now the equivalent circuit is like this. This is D1 is replaced by short circuit, and D2 is also replaced by short circuit. 10 volts here, and 5K. and here minus 10 volts, that is given in the circuit diagram itself. And assume that the current through D1 is X and current through D2 is Y. And this current is assumed to be Z. Right? So now, Y is equal to, how Y is calculated? Y is equal to, this is at this point 0 volts will become 10 minus 0 by 5k. 10 minus 0 by 5k, that is 2 milliamperes. And Z is equal to, what is Z? 0 minus of minus 10 by, so here one more resistance, 10k, sorry. This is 10k. 0 minus of minus 10 by 10k. Here 10k resistance. Here I'm showing here this resistance. Right? So 10k. Right? So Z is equal to 0 minus of minus 10 by 10k, that is 1 milliampere. And we know that by KCL, Z is equal to X plus Y from this figure by KCL, right? So X plus Y, that implies X is equal to Z minus Y, 1 milliampere minus 2 milliampere, that is minus 1 milliampere. Minus 1 milliampere is nothing but less than 0 milliampere. 0. ID is 0. That means now diode D2 is in off state, and D1 is in off state, and from this we can say that D2 is on. In this case, what we have assumed, both the diodes are replaced by short circuit, means we have assumed that both the diodes are in on state. We understood this, right? So, whereas in this case, D2 is on, that means assumption is correct. Assumption is correct for D2. Whereas, for in the case of D1, assumption fails. Assumption fail. So therefore, so now D1 must be replaced by open circuit, and D2 must be replaced by short circuit. Right? So redraw the circuit diagram like this. This is open circuit, and now D2 is replaced by short circuit, 5K. Here it is 10 volts, and this is 10K minus 10 volts. From this, I2. Now you can calculate. That means this is open circuit. The charge carriers cannot cross the infinite. Open circuit offers infinite resistance. We know that. The charge carriers cannot cross the infinite resistance to constitute electric current. Right? And hence you can say that I1 is equal to 0 milliamperes, and I2 is short circuit on state. So now calculate. So this is this way, 10 minus of minus 10 by 5 plus 10, 15K. That means 20 volts by 15K. This is 1 point, it is calculated as 1.33 milliamperes. 1.33 milliamperes. That means I1 is equal to 0. Therefore, I1 is equal to 0, and I2 is equal to 1.33 milliamperes. You can check just by calculating this, right? So, are you able to follow this? So, if you have any doubt, please comment. Please comment, right?
Okay.
So we will see the next problem. So assume that the diodes are ideal. Calculate I1 and I2. Right? So in this case, let us replace the diodes by short circuit. So replace the diodes by short circuit. So D1 is replaced by short circuit, and this is 10 volts. This is also replaced. D2 is replaced by short circuit, 10K, and here it is 5K minus 10 volts. Right? So assume that the current through D1 is X and D2 is Y. This is Z. Right? So these questions are from previous IAS as well as GATE papers only. Right? So we have taken it from previous papers on previous IAS papers only. And how Y is calculated? Y is equal to 10 minus 0 by 10K, that is 1 milliampere. And Z is equal to 0 minus of minus 10 by 5K. 0 minus, that means this is greater than 0. Hence you can say that D2 is on. D2 is on. So as we have already mentioned that in short circuit test, if ID is greater than 0, then the diode is said to be in on state. Right? That is right. So now Z is equal to 0 minus of minus 10 by 5K, that is 2 milliamperes. And now Z is equal to X plus Y, that implies X is equal to Z minus Y. Z is equal, that means 1 milliampere, which is greater than 0. Hence you can say that D1 is also on state. So both the assumptions are correct. So we have replaced D1 and D2 with short circuit. Hence, it is practically observed that both D1 and D2 are in on state. That means assumptions of both the diodes are correct. You can certify. Right? So now, so I1 is equal, now calculate I1. I1 is equal to 0 minus of minus 10 by 5K. 0 minus of minus 10 by 5K, that is 2 milliamperes. And I2 is equal to 10 minus, 10 minus of minus 10 by 15K. 10 minus of minus 10 by 15K. That is 20 volts by 15K, that is 1.33 milliamperes. So therefore, I1 is equal to 2 milliamperes and I2 is equal to 1.33 milliamperes. Right? So if you have any doubt, please comment on this problem. Please comment. So please comment. If you have any doubt, you please comment. So I will try to clarify your doubts. Right? So we will see the next problem. So given that V gamma is equal to 0.7 volts, 0.7 volts in the sense, so it is observed that the diode, the given diode is practical diode, not ideal diode. That means the potential barrier, it is assumed that the potential barrier exists, but RF is assumed to be 0. What does it mean? So in this case, once the potential barrier is eliminated, that means the voltage applied across the diode is exceeds V gamma value 0.7 volts, then the current through the diode increases abruptly, not exponentially. When the diode resistance is taken into account, then only the exponential increment through the diode current through the diode will be coming into the picture. Otherwise, abrupt increment through the diode only will current only will be coming into the picture. And find I1, I2, and V0. We'll try to solve this. And now in this case, replay both. Let us conduct the open circuit test. Replace the diodes with the open circuit. Redraw the circuit diagram. So replace the diodes by open circuit. This is 5K, 5 volts, and D1 is replaced by open circuit, and D2 also replaced by open circuit. And this is V0, 5K minus 10 volts. VA, anode voltage and cathode voltage, D1 this is. And this is also D2, VA, VC. Now calculate VA minus VC for a D1. For D1, VA minus VC is equal to 5 minus 0. Here it is 5 volts. 5 minus 0, that is equal to 5 volts. And for D2, VA minus VC is equal to, so what is VA minus VC? 5 minus of minus 10. Minus of minus 10. 5 minus of minus 10, that is 15 volts. What you have observed from this? So D2 is more heavily forward biased than D1, and hence D2 will switch on first by the time D1 is in off state only, right? So here I will write down here. So D2 is more heavily forward biased, that implies D2 becomes on first. D2 becomes on first by the time D1 is off only. Now therefore replace D2 by V gamma. V gamma is equal to 0.7 volts. Now let us redraw the circuit diagram. Here it is 5K, 5 volts, and this is replaced by open circuit, and D2 is replaced by V gamma, that is 0.7 volts. And this is 5K minus 10 volts. Here it is V0. Right? So now apply KVL. That means assume that the current through the circuit is X by KVL. What is KVL? 5 minus 5KX minus 0.7 minus 5KX plus 10. Minus of minus 10 means plus 10. So 5 minus 5KX minus 0.7 minus 5KX plus 10 is equal to 0. Is equal to 0. That means 550 minus 0.7, 14.3. That is equal to 14.3 is equal to 5kx, 5 into 10 cube, 5 into 10 cube, 10 into 10 cube, 10 into 10 cube x. That implies x is equal to 14.3 by 10 into 10 cube, 10k. That is 1.43 milliamperes. 1.43 milliamperes. Now, now calculate VA minus VC for a D1. For D1, VA minus VC is equal to, VA is how much? Here 5 volts minus 0. That means 5 minus 0, that is equal to 5 volts. So, and VA is equal to, VA calculate. How VA is calculated? 5 minus 5kx. 5 minus 5kx. That is equal to 5 minus 5 into 10 cube into 1.43 into 10 to the power of minus 3. That is equal to I have solved here. Meanwhile you do this problem, right? So just calculate. VA is equal to minus 2.15 volts. Please check which is less than V gamma. That is 0.7 volts. So, and hence D2 is off. Therefore, D2 is off. It means which is less than V gamma. Less than V gamma in the sense, what does it mean? D1, sorry, D1 is off, not D2. D1 is off. DT is already on. Correct? So, D1 is off. Why? Because, so, minus 2.15 volts, which is not at all sufficient to eliminate the potential barrier. And hence, current conduction will never takes place through the diode. That is why it is in an off state. D1 is off. Right? So, now I2 is equal to, what is I2? Now you can calculate this. Now it is replaced. Now the equivalent circuit is 5 volts, 5K, and this is replaced by open circuit, 0.7 volts, 5K, and V0. So from this, we can say that I1 is equal to 0 and I2 is same as X. That means 1.43 milliamperes. 1.43 milliamperes. I2 is equal to. Now we calculate V0 just by applying KVL. So V0 is equal to V0 minus 5K. Here it is minus 10 volts. So V0 minus 5K I2 minus of minus 10. That means V0 by KVL. V0 minus 5K I2 minus of minus 10 is equal to 0. That implies V0 is equal to 5 into 10 cube into 1.43 milliamperes minus 10 is equal to 0. That is what I have calculated as minus 2.85 volts. Please check. Minus 2.85 volts. Have you understood this? Right? If you have any doubt, please ask me. Then I will try to clarify your doubts so that our interaction will be very good. Right? We are expecting so good comments from the students, and hence we can deliver. We can give the best lecture. right? We will try to, so expect that means please comment on this.
కామెంట్స్ వచ్చాయి చూడండి.
Okay, we will try to solve the next problem. Assume that the diodes are ideal. That means V gamma is assumed to be 0. Find I. So the current I in this case, right? So here, what you have observed from the circuit diagram? So multiple voltages pointing to the same node here, which is practically not correct. That is impracticable. That is not possible. That means a short circuit test is not possible in this case. If you apply short circuit test, then multiple voltages pointing to the same node, which is impractical. That is never possible in practice. That is why short circuit test is not applicable in this case. So only the way to observe whether the diodes are in on state or off state is just by conducting open circuit test. Right? Please remember that when to conduct short circuit test, when to conduct a open circuit test. Right? So otherwise counterpart also we should observe practically. Right? So I will write down here short circuit test is not applicable here. Not applicable here. So therefore replace the diodes. Replace the diodes by open circuit. Replace the diodes by open circuit. This is 1 volt, 2 volts, and diode 3 volts. This is 2K. This is 10 volts and output voltage. All right. So now the diode, that means the current is assumed to be from P to N, not from N to P. That is why 10 minus for diode D1. So VA minus VC is 10 minus 1 volt, 9 volts. Please observe here. Here it is, this is the anode terminal and this is cathode terminal. And what we have assumed in the case of short circuit test, the current direction is assumed to be from a P to N, not from N to P. That is why 10 volts minus 1 volt for diode D1 and 10 volts minus 2 volts for diode D2 and 10 volts minus 3 volts for diode D3 will be coming into the picture. Right? So I will write down here. For D1, VA minus VC is equal to 10 minus 1, 9 volts. And similarly, for D2, VA minus VC is equal to 10 minus 2, that is 8 volts. Similarly, for D3, VA minus VC is equal to 10 minus 3, 7 volts. That means what you have observed from this. So from this we can say that D1 is more heavily forward biased and hence D1 will be switched on, will become on first. And by that time D2 and D3 are said to be in off state only. And hence D1 can be replaced by short circuit. Replaced by short circuit. Right? So I will draw the circuit diagram here, equivalent circuit diagram, and this is replaced by short circuit 1 volt, and this is open circuit D2, and D3 is also replaced by open circuit, 2 volts, 3 volts. This is 2K, then 10 volts I. And now the voltage here is 1 volt. Right? So now calculate VA minus VC for D2 and D3. For D2, now you calculate VA minus VC is equal to 1 minus 2 volts. 1 minus 2, that is minus 1 volt, which is less than V gamma. And hence, D2 is in off state. And similarly, for D3, VA minus VC is equal to 1 minus 3. That is minus 2 volt, which is also less than V gamma. Therefore, you can say that D2 and D3 are in off state only. Only D1 is in on state, and hence we have replaced it with a short circuit. Now we can calculate current I. Therefore, that means the equivalent circuit corresponding to this is this is 1 volt and 2K and I. Now, I value can be easily calculated. That means 10 minus 1 by 2K. That means 9 volts by 2K, 4.5 milliamperes. 4.5 milliamperes. Have you understood this? Right? So, the very important thing in this case is to be noticed is, right, if multiple voltages point to the same node, which is not, that means not correct. So that means practically not correct. That is why short circuit test is not applicable in this problem, in this case. Whenever you come across this type of problems, you observe whether the short circuit test is can be applicable or not. If it is not applicable, then you must go for open circuit test. Have you understood this, right? So, and so please comment on this. Okay, so we will discuss the next problem. Right? So the IV characteristics of diode is given by I is equal to V minus 0.7 by 500 amperes if V is greater than or equal to 0.7 volts and 0 amperes if V is less than 0.7 volts. That means, what does it mean? Diode is, in this case, diode is forward biased in conduction mode. So diode in a conduction mode, I is equal to, diode is forward biased in conduction mode. Diode is in conduction mode. I is equal to V minus 0.7 by 500. That means, what does it mean? From this, V is equal to, you can say V is equal to 500 high plus 0.7. V is equal to 5, that means voltage across the diode is equal to 500 I plus 0.7. Right? So, by KVL, what you have to calculate? The current in the circuit. This current must be calculated. Current through the diode is to be calculated. Then, by KVL, 10 minus 10 cube I minus V is equal to 0. That means 10 minus 10 cube into I 10 cube I minus V means minus 500I minus 0.7 is equal to 0. Just we have substituted this V value in this expression. That's all. That means 10 minus 10 cube I minus, that means 9.3 is equal to 1500I. That implies I is equal to 9.3 by 1500. As simple as that. Now just calculate this value and please tell me what is the I value. I is equal to, I have calculated here, I is equal to 6.2 milliamperes. This is also one of the important problem. Just observe simple only. Diode is in forward bias. Forward bias means it is in a conduction mode. In conduction mode, that means V gamma is greater than or equal to 0.7 volts. Now the diode is said to be in conduction mode. In conduction mode, the equation for current is given, that is V minus 0.7 by 500. Just by cross multiplication, we can get this equation. V is equal to 500I plus 0.7. Right? So by KVL, 10 minus 10 cube I minus V is equal to 0. Just substitute V value in this expression. So thereby we will get 9.3 is equal to 1500I. So and hence I is equal to 6.2 milliamperes. Have you understood this? Right? So, and the next one is, assume that V gamma is 0.7 and find I1 and I2. So in this case, replace the diodes by open circuit. Right? So let us redraw the circuit diagram. This is 10 volts, 1K, and this is replaced by open circuit. And D2 is also replaced by open circuit, and 1K, 80 volts. Now calculate. So this is VA, VC, D1, and VA, VC, D2. Now calculate VA minus VC for D1, and similarly calculate VA minus VC for D2. Right? So VA minus VC for D1 or D2, that means observe which diode is more heavily forward biased. Right? So the diode which is more heavily forward biased will become on first, and the remaining diode, the other diode is in off state only. Can be replaced. That means the diode which is on first is replaced by V gamma, that is 0.7 volts, and the other diode is replaced by open circuit only. And so just assume that the current through the circuit is X. Now by applying KVL, just find the X value. Right? Now calculate VA minus VC, VA minus VC, VA for D1. So that means 10 minus 10 cube X. Observe whether VA minus VC for D1 is D1 or D2, which is less forward biased. So is greater than or less than V gamma. If it is less than V gamma, then it is said to be in off state. If it is greater than V gamma, then it is said to be in on state. As simple as that. Right? So let us see. So here for D1, VA minus VC is equal to 10 minus 0, that is equal to 10 volts. And for D2, VA minus VC is equal to, here it is 10 minus of minus 18. 10 minus of minus 18, that is equal to 28 volts. That means what does it mean? D2 is more heavily forward biased. More heavily forward biased. so that it becomes on first. So therefore, D2 can be replaced by V gamma, 0.7 volts. Now replace D2 by V gamma. Is it redraw the circuit diagram? 10 volts. This is 1K. This is replaced by 0.7 volts and 1K. This is 18 volts. Right? So assume that the current through the circuit is X. Now calculate X just by applying KVL. Right? So how we can apply KVL? By KVL. So 10 minus 10kx minus 0.7 minus 10kx minus of minus 10, that means plus 18 is equal to 0. That means 10 plus 18, 28, minus 7, 27.3. 27.3 is equal to, so 10x 20 into 10 cube x. That implies x is equal to 27.3 by 20. Just calculate this. So you will get 2k, sorry, not 20, 2k. This is 1k. Sorry, 1k. This is 2k. Now, what you will get? 13.65 milliamperes. You just check whether it is correct or wrong. Right? 13.65 milliamperes. So, and now calculate VA for diode D1. For D1, VA is equal to 10 minus 1kx, that is 10 minus 10 cube into 13.65 into 10 to the power of minus 3. That is how much it is? Just please calculate. This is minus 3.65 volts, which is less than V gamma. Therefore, D1 is in off state. Therefore, D1 is off and D2 is on. So the current through D1 is I1 is equal to 0 and I2 is equal to 13.65 milliamperes. 13.65 milliamperes. As simple as that. Just apply open circuit test. That means conduct open circuit test and observe whether the diode is in on state or off state. So just by observing whether it is greater than or equal to V gamma. And so replace the diode with its equivalent circuit. Right? If it is on state, can be replaced by 0.7 volts. And if it is off state, then it is replaced by open circuit. Right? And calculate the current through the diode. So, and hence easily we can calculate the current through diode D1 and D2. Thank you, my dear friends. Tomorrow we are going to discuss problems on clipper circuits and clapper circuits, which are very, very important and which definitely I am promising you that which definitely will draw your attention. All right. So, and please comment on this lecture. So, and hence I can improve. That means I can give the better lecture among the students. Please comment on this. Okay, thank you very much. Right, so please attend for the tomorrow's lecture, so that definitely I am promising you that you will enjoy the lecture. Why? Because the problems are very important as well as very interesting also. And I told you that. So in Zener diode also can be used in the Kepler circuit. What is the operation of Zener diode? When it is forward bias, acts like normal diode. On what basis we can say that the Zener diode under forward bias conditions acts as normal diode means it is practically found that the V gamma for Zener diode under forward bias conditions is 0.7, which is same as ordinary diode. Based on this practicality, so we can certify that under forward biased conditions, Zener diode acts as a normal diode. And next one is Zener diode works, that means it will introduce current conduction under reverse biased conditions. Right? When it is reverse bias, but not in breakdown. So what is the basic function of the Zener diode? Voltage regulator. Right? Once it enters into the breakdown, then it is able to supply constant voltage throughout the operation. But if it is reverse bias but not in breakdown, then the Zener diode is replaced by open circuit, and hence the Zener diode is said to be off state. And after that, if it is greater than Vz, greater than or equal to Vz, then it acts as voltage regulator. Based on this, we will try to do the problems. Thank you very much.